Good morning, students. I am Proshun Kumar Ghoshal. I am here to demonstrate on the topic that is pH and the pH scale. So, pH means power to hydrogen. Today, I'll try to cover the basics of the pH scale, the calculations, and also the apparatus used and the limitation of the topic, and also the advantage of the topic. Now, it was Sorensen who tried to demonstrate first time and who proposed this scale. What is it? So we can say that pH of a sample may be defined as the logarithm to the base 10 with respect to the activity of hydrogen ion. So we can say that activity of hydrogen ion, this is the thing. Now if the sample is very dilute, that means if concentration is much lesser than 0.01 m, then in such case we can write activity equal to minus of concentration of H plus, like this. But since activity is dimensionless, so we can write also the unit like this, mole per liter. Now what are the apparatus used? In these days in the lab we use the pH paper. Yes, pH paper can be used because it works with an accuracy of -5, but there are some stipulations. If the pH of two samples, suppose they are very close to each other, it becomes a headache or problem for us. So we have replaced this with another apparatus, which is obviously in these days it is electrically operated. It is the electrical apparatus. Now this pH scale is called the electroanalytical pH scale or the pH apparatus. It works with an accuracy of 0.001. So these are the two apparatus. Now coming to the advantage, you can calculate and you can even find out the pH of those substances which are arenous acids and arenous bases. That means those acids which can release the H plus and those bases which release OH minus, and even those which cannot or which don't have H plus or OH minus. Yes, there are some acids in which we don't get H plus. They are obviously out of the realm of your syllabus, but still for them also this is applicable. Now what are the limitations? And before limitation, I'm just coming to the topic. Let's see the scale. Now any solvent have a tendency like this. Suppose we take water, because water is a universal solvent. So water, it breaks down like this. This is called autolysis of water. It is the theory of solvent. Now, as per our calculation, for 1 liter water, which is obviously pure, and you are taking the temperature as 298 Kelvin or 25 degrees centigrade, which is the room temperature, the concentration of H plus is found to be 1 into 10 to the power 7. M means moles per liter. In the same way, this also comes to be the same. These were calculated analytically. Now we apply the definition. What is the definition? You are using the negative logarithm to the base 10, and since activity equals concentration, because we are dealing with dilute things, so we can write negative of log of H plus equal to negative of log of 1 into 10 to the power 7 m, or since we are working with it, so we may not write the unit, doesn't matter. So it becomes minus log of 1 into minus log of 10 to the power 7 minus, it is the rule of the log, so we put the plus sign here. So minus log means 0, and it is 10 to the power minus 7. So 10 to the power minus 7 means minus 7 will come, and you are already having a minus log of 10. So minus of minus 7 means plus 7. So 7 log 10 equal to 7 log 10 means 1. So we can write pH for any water which is very much pure at 298 Kelvin, it is 7. In the same way, if you calculate, you will find also POH is 7. Now this is a scale to measure the H plus, this is a scale to measure the OH minus. Now this scale POH we don't use these days. A question may come, why? We don't use them because not all bases but only some alkalis can release the hydroxide ion. So it is applicable only on that, so the rearm is very, very less. Now again, if you follow this equilibrium, if you try to find out the constant, water dissolution constant, it becomes like this: H plus into H minus. Again you take the negative log, you get minus log of H plus, and if you solve it, so plus minus log of OH minus. So this you can write as pKw, this you write as pH plus pOH, and the value is 7 plus 7 equal to 14. So we can write pKw equal to 14 equal to pH plus pOH. Now with respect to this or based on this, we are using either the pH paper. pH paper gives us the indication by change of color, and pH meter, if you say, which is the analytical one, it gives you the reading directly. So we can segregate this as 0 to 7 and 7 to 14. Now if the pH value is equal to 7, it is neutral solution. If the pH is lesser than 7, it is acidic, and if the pH is greater than 7, it is basic. Now again, if you try to segregate this and this, you take 0 to 4 and 4 to 7. 0 to 4 means very strong acid, 4 to 7 means moderately strong acid, and very near to 7 means weak acid. 7 is neutral. So obviously things are below 7. Again from 7 to 14, something starting from the value after 7 to 10, moderately weak base, and from 10 to 14 it is a very strong base. Now a question comes, what are the limitations, as I have discussed before. Now these can be covered at present. See, first of all, it is not the case that we are dealing with the dilute solution always. Yes, dilute we try to use, it is having significance, but not all the time we are using dilute. Sometimes we do use concentrated solutions of acids and bases. Now if the solution is very, very acidic, it goes without saying, suppose you are taking the concentrated HCl which is present in your lab, the bottle in which you are buying the HCl for the school, you will find the pH is much much below 0. Why? Because in those cases it is not 1 normal, 2 normal or something like that. It is more than that. It is containing about 36 normal. So value is negative. Any acid which is very, very concentrated, the strong mineral acids, the values are always coming negative. Again, you see there are some samples, like if you are preparing 1 mole of one mole of CSOH. 1 mole of NaOH is 10, but 1 mole of CSOH it is coming 18. You are having scale as 14, but you are getting more than that. So these are some of the limitations. And last but not the least, there are some acids which are very, very, very weak. In pH meter, it will show you 7. Now see the one, it is showing you 7. 7 means neutral, but it is acidic in nature. Again, you see the same one with some of the bases. There are some organic bases which are very, very, very weak base, like aniline. If you take aniline, you will find the thing. No, those pH couldn't be calculated by this. So I hope I am clear with the topic in this 10 minutes demo. So just I hope the thing you understood well. Again I repeat, what is pH? It is the negative logarithm to the base 10 with respect to the activity of hydrogen ion. And since the solution is very, very dilute, we consider, so we can replace this by this. So I hope I am clear. So this is the thing, but generally if you say, we don't even care for this, we don't even need to care for this. So this is the thing that we have discussed today regarding pH, and I hope the thing is very clear. Now numericals may come. Suppose you have been asked, calculate the pH of a solution containing 10 to the power minus 4 H plus concentration. What to do? In this case, again you take pH equal to minus log of H plus. Log of H plus is given, so minus log of 1 into 10 to the power minus 4 has been given to you. So minus log, take this like this, log 1 plus log of 10 to the power minus 4. So log 1 means 0. So minus 4 into log 10. So you get minus minus plus 4 into log 10 means 1. You get 4. So pH is 4. So this type of numericals are the applications of the topic that has been explained. So I am just ending my topic here. Thank you.